Hello, I do hope you're keeping well. Today I'm going to be going over a BMO1 problem. So we're given precise percentages here, 30, 40, 50, 60 and 70%. So I converted them all into fractions. And you can see here I've either scaled them down or scaled them up. There's a reason why I've done this. Because we want the smallest possible number of games. And we also know that they're taken at 5 different points throughout the day. Therefore, the total number of games is always increasing. So, I've simplified a few fractions and I've also scaled them up, as I said, because I want to take the smallest possible number of games to start off with. You've probably noticed that for 50% I've only written a half down, because that is the first percentage I'm going to take. What does this actually represent? Well, we're saying that one game is 1 out of 2 games. So we're starting off with 2 games, the smallest possible number of games. Well, now we need to search for the next smallest denominator. So we're looking at 2/5 and 3/5. So let's start to draw a diagram to represent our information and thought process. So we definitely know we're going to start off with 50%, because that's the minimum denominator we have. Now with 50%, we can go down to 40 or 60%. Suppose we chose 40%. Well, what's the next smallest denominator? It's going to be 10. And we could choose 3/10, 6/10, or 7/10. But are all of these possible? Well, there's a way to check this out. Remember how we represented the fractions as the total number of wins over the total number of games? I'll just label that as W over G. Say the next fraction we pick is W plus K over G plus L. So K is representing the number of wins from point G to point G plus L. And L is looking at the difference between the number of games played. From here, we can say that W plus K minus W has to be less than or equal to G plus L minus G. We can cancel them out. Therefore, K has to be less than or equal to L. And hopefully this makes sense logically. If we think about 50 to 40, say, we took a half to 2/5. So we're saying 1 win out of 2 games, 2 wins out of 5 games. Is that possible? Well, yes, because we've won 1 game in 3 games' time. So that is possible. So, let's go back to our question. So we had to choose either 30, 60 or 70%. So I'm going to write these all down, 30, 60 or 70. Let's say we go down the 30 route. So we have 3 wins out of 10 games. Well, our next possibility would be 60 or 70. Can we go from 30 to 60? Well, we're going from 3/10 to 9/15. That's not possible because the difference between the numerators, 6, is greater than the difference between the denominators, 5. What about taking the next fraction in the 60%? So 12 out of 20. Can we go from 3/10 to 12/20? Yes, that does work. So 60 works. And then we're going to go to 70. So 12/20 to, well, we can't go to 14/20, so the next number would be 21 over 30. Can we go from 12 over 20 to 21 over 30? Yes, we can, because the difference is less than the difference between the number of games taken. So, what do we conclude from this avenue? Well, we've ended up at 21 over 30. 21 wins out of 30 games played. So the smallest possible number of games, when we go down this route, will be 30, the denominator. So let's make a note of that. And I'm actually going to just move my diagram a little bit so a bit more space later on. And I'm actually going to just move my diagram a little bit to have some space afterwards. We concluded that when we go down this route, we play 30 games in total. Okay, now let's go back to the 70. Is that possible? Can we go from 30 to 70? We'd be going from 3/10 to 14/20. That's not going to be possible. Can we go to 21 over 30 though? No, we can't. So this route is not possible. Okay, let's backtrack one more step. So 50 to 40 to 60. So 1/2 to 2/5. We already established that that's valid. And then 2/5 to 6/10. Is that possible? Yes, it is. So from 6/10, where can we go next? Well, we have either 30 or 70, don't we? So I'm going to just draw these avenues, 30 and 70. Can we go from 6/10 to 6/20? Yeah, we can. We're just saying that during those 10 games, from the 10th to 20th game, he hasn't won any games at all. So he's lost those 10 games. So yes, that is possible. Then here, can we go to 70? 6/20 to 21 over 30. Now that is not possible. Think about it this way. We're going from 20 to 30 games. The maximum possible games he could win is 10. So we're doing 10 plus the previous 6 wins. So our maximum that he could do is 16 wins out of 30 games. And 21 exceeds 16. So we cannot have that either. Now, let's go from 60 to 70. So the only route we could take is 30. But first, we must check whether we can actually go from 60 to 70. Okay? So, can we go from 6/10 to 14/20? Yes, we can. What about from 14/20 to 9/30? We've got a problem. Our number of wins is decreasing. But we know that this can't ever happen. We can't go from 14 wins to 9 wins. As we said before, the number of wins will always be increasing or stay the same. But it can't ever decrease. So even this route we have to reject. So you can't even have 40 to 60. What about 40 to 70? Could that work? Well, we'd be going from 2/5 to 7/10. And that is our maximum. So it does work. From 70, where could we go? Well, we either have 30 or 60 to choose from. Can we go from 7/10 to 6/20? No, you've got the same issue as we had before. So we can discount that immediately. But can we discount that immediately? Because, no, we can't go from 7/10 to 6/20 because the number of wins is decreasing, which we know is not allowed. But we could go from 7/10 to 9/30. We're saying that he's won 2 games out of 20, which is possible. Maybe he's just having a bad day. So actually, we can go down this route. So let's remove our cross here. And put 30 back. So we're saying from 9/30 we could go to 60%. But then that would mean we'd have more than 30 games, right? Because we have 9 over 30 games already, and we're going to have to just go up to 35 games. But why would we do that when we've already established 30 games here? We're looking for the minimum, not the maximum. So really, there's no point going down this route if we know that we can't beat 30 games. So let's stop here with this route. Now, 50, 40, 70, 60. Is that possible? So we're going from 1/2 to 2/5 to 7/10 and then to 60%. So we could go from 7/10 to 9/15, so that's all right. Then from 9/15, what should we do next? We have to go to 30%. Can we go from 9/15 to 6/20? No, we cannot, because our number of wins is decreasing here. But can we go from 9/15 to 9/30? Yes, we can. We're just saying that he hasn't won any more games from the 15th game to the 30th game. So once again, our minimum number of games in this route is 30 games. So we can't beat that just yet. Now, we've explored 40. Let's now explore 60. Right, this is going to get a little bit cramped again. So let's just move this about. Right, 50 to 60. So a half to 3/5. That's okay. Now from 60, we could either go to 30, 40 or 70. Okay, so we've got a few routes we could take here. Got 30, bit dodgy 3, but okay. We've got 40 and we've got 70. Can we go from 3/5 to 3/10? Yes, we can. We're just saying he hasn't won any more games from that point. Now, with 30, we can either go to 40 or 70. So 3/10 to 6/15, and that is possible. Okay, so we've got 6/15. Can we go from 6/15 to 70%? Well, 6/15 to 14/20. That's not possible. Can we go from 6/15 to the next biggest fraction, 21/30? Hopefully you said yes. It is our maximum, but it does still work. He could just be very, very lucky and win those 15 games. But again, we've concluded that we've got 30 games overall. So we've just got to keep on going and hopefully we can cut down on 30 games. So after 40, I went to 70. Right, what about 50 to 60 to 40? So 1/2 to 3/5 to 4/10. That's all right. From here, you could go to 30 or 70. 4/10 to 6/20. Yeah, that does work. And then from 6/20 to 21/30. Now that cannot work. We can't go from 6/20 to 21/30 because the difference in the numerators is greater than the difference in the denominators. Again, we could always scale 70% up, but why would we when we've already got 30 games? We don't want to go any further than that. So I'm going to end this route here. Now, what about from 40 to 70? So what did we have? We had 1/2 to 3/5 to 4/10 to 14/20. From 14/20, can we go to 30%? Well, no, not really. 40/20 to 9/30, our number of wins, we can't decrease that, can we? So again, I'm going to end this route here. Now, our final branch, 50 to 60 to 70, 1/2 to 3/5 to 7/10. From 7/10, we can either go to 30 or 40. Seven tenths to 30%, well, we'd choose 7/10 to 6/20. Now that can't work. But what about 7/10 to 9/30? Yeah, that does work. But then from 9/30, we'd have to go to 40%, our remaining percentage. But then again, we'd be increasing the number of games played. So I'm going to stop here. What about 70 to 40? 7/10 to 6/15. Nope, that's not going to work. What about 7/10 to 8/20? Yeah, that would work. We've won a single game out of 10. Now from 8/20, can we get to 30%? Yeah, we can. We can choose the fraction 9/30 and that would be valid. So again, we've got 30 games. Therefore, the smallest possible number of games that they've played would be 30. I hope you enjoyed that BMO problem. Of course, I'm sure there'll be multiple ways to solve this, but this is what I thought of initially. Have a great day, and I'll see you in my next video. Thank you for watching. Bye!